Hi everyone. Today we're going to talk about how to sketch sine cos graph, but this time we will include the horizontal translation in. Okay, and with vertical translation, we're going to talk about that in another video. All right, let's get started. So our first step when we sketch this one is we're going to find the amplitude. With the amplitude, it's always the number in front of sine or cos. So in this case, it's A. But remember, you need to take the positive number only. Now the range will be negative A to A. Okay. Step three is we're going to find a period. So the period, as we know, the last video is 2 pi over n. And n is a number in front of the variable. So n is right here, and you can see. All right. And then we going to have a point. So, but before we do that, we're going to get out one step first. So each step is a quarter of the period. So one step is a quarter times 2 pi over n, and we work it out. All right. So we're going to have the original point. So this is the point before the translation happens. So I always start from zero, and then you're going to add a step each time. So from zero, and then you just keep moving, keep adding one step, and then you keep doing that. You're going to have all the points. So this is how you sketch without the translation. Then after you do that, you're going to consider the translation here. So this one here. So here is epsilon. So if it plus epsilon, this means that you're going to move to the left. And if you have minus epsilon, this means you have to move to the right. Now, once you have this idea, see the original point, you have all the point here. Your final step is you're going to get what is the actual point, the final point that you're going to have on the graph. So which each point you're going to add or subtract the epsilon, the translation. Okay, if it moves to the left, you're going to minus. So you do the opposite of that. If it moves to the right, you're going to plus epsilon. So how does that, if you imagine the graph, think about I have a sine graph. Let's think of transformation for a bit. So this is the original sine of x graph, right? With the 1 and negative 1, and the period is 2 pi. Now, when you have a dilations, if you have y times sine of nx, then the amplitude change from negative a to a now. And then because of the n, the period will get smaller swing by n if assuming if n is bigger than 1. So you have here, sorry, it's not nice enough. So this is 2 pi over n. Now, uh, and then so you go from there to there, that's the dilation. Then you think about the horizontal translation. If you has move epsilon to the right, to the left. So let's say in this case, y times sine of n, and I do f plus epsilon, for example, and assuming epsilon is a positive number. So this means I have to move more epsilon unit to the left, right? So think about the original graph like that. Now you have to move all the points to the left. So you can see this point here, when I move epsilon unit to the left, so I'm going to minus epsilon, and it might become here. Okay, so my starting point will be somewhere on the left-hand side here. And this point, when I move, then it's somewhere on the left side. So I keep everything, you have to move epsilon unit to the left. So you move like that. So your graph might look like that, for example. Okay, so the starting point is different. Right, so that's the idea. And we're going to do an example of how to apply this technique. All right, so underneath here, I do have an example with the graph and the domain as well. So my first step is I find the amplitude equal to the range will be -3 to 3. Okay. Now the period is 2 pi over n, and as you can see, n is a number in front of t, which is the coefficient 2, so pi. Now this step that I have is 1/4 times a period. So I would have 1/4 times pi is pi over 4. Okay, so the original point, so the point original before, I haven't done this translation yet. Okay, let's forget about that for now. So the original point I have will be 0. The step is pound 4, so I do 0, pound 4, 2 pound 4, 3 pound 4, and 4 pound 4, which is 1 pi. Okay, so if you think about, because I haven't done the horizontal translation, I just do basically dilation. You can see these are the points. So you have 0, pound 4, 2 pound 4, 3 pound 4, and 4 pound 4, which is pi. So the range is -3 to 3. So you can see this is the original graph. Okay, this is before I done the translation. Now I'm going to add in the translation in. So what's the translation here? Here I have minus pound 4. So this means that it's translate pound 4 to the right. So the graph you have at the moment here, you're going to move each point. So this point here, you're going to move about pound 4 to the right. So this point become this point here, right? And then keep going pound 4 here, you move about pound 4 to the right. So you move in this direction. So pound 4 become 2 pound 4 and so on. Okay. So that's why I have the final step in my previous talk. So the final point, each point here, you plus pound 4 to the right. So you're going to plus 2 pound 4, all of them. So plus pound 4, plus pound 4. So 0 plus pound 4 is pound 4. Pound 4 plus pound 4 is 2 pound 4. As you can see here. So 0 have become pound 4. 0 have become pound 4. Pound 4 have become 2 pound 4. Pound 4 become 2 pound 4. So if you keep doing that, 2 pound 4 become 3 pound 4. And then 3 pound 4 become pi. So the last point, when I move this point here, pi become 5 pound 4. So my final graph will look like this. Okay, so I done. Okay, maybe I delete it later. So my final graph will look like that. So you can see the transformation happening here. But because you sketch in the final graph, you can just rough. You don't have to do the original one. Just this will just help you understand what happened. But I just delete that. So there you go. You have a final graph here, pound 4 and 5 pound 4, which is exactly how they want in the domain. All right. Now, pretty much the same thing for now we do again, but this time we're going to do this example here, the cost graph. Pretty much the same thing, except that cost will start from the maximum this time. Okay, let me just drop this out and we do again. All right, so what do we have? The amplitude for this equation will be 2. The range will be -2 to 2. The period is 2 pi on n, and it's 3. One step of a period, 1/4 of the period is a quarter times 2 pi on 3, which gives you 2 pi on 12, which is pi over 6. So the original point is 0, pi over 6. And then you keep going. You just keep plus pi on 6 each time, 2 pi on 6, 3 pi on 6, 4 pi on 6, and yeah, that's it. Which is 4 pi on 6 is 2 pi on 3. That gives you a period. Okay, so what does that mean? So now if we ignore the translation, we have the range is -2 to 2, right? And these are the original point. You have 0, 1 pi on 6, 2 pi on 6, 3 pi on 6, and 4 pi on 6. I haven't simplified here, but we do it later when we finish, okay? The cost graph, we start from this is the cost graph, cost start from the maximum, and then middle, minimum, middle, maximum. Let's do in dotted line. So the cost graph will look like that. Okay. Now, if you think, now you do the translation. So think about here, I actually adding how much pound rate, and because it's plus, I move pound rate to the left. Okay. So I need to think how much is pound rate to the left. So you can see on the scale, this is pound 6, this is 2 pound 6. 2 pound 6 is 1 pound rate, right? So that much to scale, as you can see, 1, 2, 3, 4. So 2 pound 6, you have to move 2 pound 6, which is pound rate, but this time you move to the left. Okay, so this point here, if I move 1, 2, let's extend the line. So, right. So this point, I move pound rate to left. So this point become here, which is -2 pound 6 or pound rate. Okay. Then this point, I move to the left by 2 units, 1, 2. This point will become this, just doing cross. And then this, I move 1, 2, become here. This, I move 1, 2, become here. And then 1, 2, become here. So you can see my final graph will look like that. Okay. And then you can rub out the original graph if you want to. This look a bit really messy. Okay, there you go. You have a final graph, and then 2 pound 6 make it nicer as pi over 3. Yeah, which is exactly what's the domain one. Yeah.